my teams before we go ahead and get into this. So just give it a quick second. Alrighty, notification has popped up and we are good to go. So, ladies and gentlemen, welcome to what I can only say is the harder part of this course. What you guys learned before this is now going to be basically ramped up to 100%. So, yeah, enjoy. This is before we begin the tutorial, gotta go over a couple things. A lot of you guys not using a lot of the help methods that are available to you guys. We have those office hours. At most, we get 1 to 2 people per office hours. Like, we're doing those for you guys. We really highly recommend, if you have any questions, come to those office hours, because a lot of the responses we got from that test, the survey I put, is a little worrying, considering like none of those questions except question 5 and the bonus were considered hard. I gotta state that outright, because if you guys consider that hard, you will fail the final exam. Because the final exam is going to be a minimum of 7 questions and contain a lot harder content. Anyways, now that that's out of the way, let's take a look at errors and exceptions. This is going to be the easiest of the new topics we're covering, because it's something that you guys have already been subconsciously dealing with in the assignments. We've just never explicitly stated it. So when you do an assignment, you guys have been very, very keen to ask questions about many of the different error messages that Python will give you. Syntax error, value error, type error, anything that the code basically screams at you and says you screwed up. That's what this tutorial is all about. We're going to be not looking just at those errors. We're going to be looking at how to deal with those errors, how to catch them before they happen, how to manually throw those if we choose. Basically, we want full control over how our code operates. If we divide by 0 and we know we divide by 0, instead of throwing a division by 0 error, what we might do is we might catch the error, and before doing the calculation, we might say, no, return false. Or what we might say is, if you input a string into a function, we could throw an error. We could say, nah, string's not a valid input. You guys have been considering things like that, but this is the lecture this is the tutorial where we explicitly state these types of scenarios. So I'm going to be taking it part by part. As you can see, there's not a lot in this tutorial. There's like 4 example code problems. So we'll be done quick, and then you guys can ask any questions you need. So let's take a look at what I think was the first actual example of someone finding an error or finding an edge case that would cause an error. And it was a question regarding division by 0. Now, it's not the exact question. The exact question was on assignment 1 in the quadratic formula question. Someone brought this up, but I picked one that's easier to explain it, in my opinion. The mean of a data set. You guys have probably all seen the mean of a data set. You could do it in one line by this point. Sum ls divided by length ls, where ls is my list, some sort of list. I don't know what type, but I know it's a list. Someone brought up a really good edge case. Does anyone want to take a guess at what that edge case is? Assuming the input's a list, I should say. All right.
Empty list?
Empty list, exactly. So what happens if I code, or if I try to do print mean of an empty list? Well, so what would happen? We would take the sum of every item. Well, that's empty, so 0. Then the length of the list, 0, and we get 0 divided by 0. Uh-oh. 0 division error. Division by 0. Well, that's an issue, because you can't divide by 0. Now, what you guys would have done before this is if length of ls equals 0, return false. Something like that. Let's just say that's what the question wanted. And that does work. That works as intended. However, what about the edge case where we pass in a string saying hello? Well, there is no plus operation. Like there's no sum of a character. You can't take hello and add H and E and expect to get something in English. So that's an issue. And then we would have to go, well, now I have to do if type ls equals string return whoops or something like that. And then you've got to be like, well, okay, what if I'm now dealing with what if they pass in too many arguments? If I do one, or if I do a list of 1, 2, 3, sorry, and then if I pass in another list of 4, 5, 6, well, that's a whole new error called type error. So now I'd have to account for if there are multiple errors, but I can't account for multiple errors. It's a crapshoot. It is a massive, massive crapshoot trying to account for every error manually. Luckily, we don't have to account for every error manually. Python has done that for us with something called try and except. Try means attempt code, and if code works, it is very much going to try to do sum, try to do len, try to do sum divide length, and then try to return it. If for any reason it fails, it then enters the except block. This is very similar to your else block. If try was the if, except is the else. Now there are two types of excepts. There is except just generic, where you just type except. This is literally a one-to-one translation with else. However, there's except specific. So I could say except zero division error. This is essentially your else if, your elif, if you want to think of it that way. So try is almost like your top level if branch, where if code works, lovely code works. Except something is your generic elif. It's not quite else, but it's in exception to this. And except is your final layer. In Python, it is advised you never just use except. What I advise is you guys do except exception, and you could also give it a variable. So except exception as e. Now this exception is saved to the variable e. The reason we do this is because if you guys have had an infinite loop, you would know that if you press Control C, it cancels a loop. Well, except actually won't allow that, because canceling a loop is a Python exception, and except will catch that exception. So what we need to do is we need to actually catch proper exceptions, not keyboard interrupts. It's a side note. In a test or exam, you will be able to do this. Test and exam, this is totally fine, but it is advised you do this. Anyways.
Sorry, I think I'm a little bit confused by that. The reason that we're saying exception as e is because otherwise it's not. Sorry, could you just repeat that one time?
Yeah. So let's I can do a quick example. So while true, continue. I'm going to make an infinite loop. This infinite loop, whoops, I have to actually have an except block because it's continuing. Apologies. So if I make an infinite loop, notice how it's infinite. If I press Control C to break the loop, or if I use the stop button, notice how it says keyboard interrupt. Keyboard interrupt is not an error. It is Python forcefully stopping your code. However, except is general. Keyboard interrupt will get caught by exception. However, keyboard interrupt is not an exception. So when we specify exception as E, only exceptions will get caught. meaning now I could, in theory, run this. So
Otherwise,
if
it would like if you
would
have
just-
the keyboard
it would go
interruption,
forever. So here, I can do this. Print nope. So on accept, I can try stopping it and see how it prints nope because the accept saw it.
Got it. Thank you.
No problem. And then just so that way I can actually show what happens when I do accept exception is E. If I run it again and I stop the cell, notice how it's an error now, a proper error, because it's not an exception anymore. It's a weird little thing Python does. Nobody likes it. However, like people who hardcore code Python have just come to accept it at this point. So let's code this problem to be bulletproof. What we can do is we can have the zero division error. We can specify that, and what we'll do is we'll return false. And then on any other generic exception, we don't know what the exception will be. What we can do is we'll return a string saying whoopsie. So on this problem with an empty list, what should happen? It should return false. Woo! What happens if we pass in too many arguments? Well, that was a type error, meaning that it should. That's the type error is not happening in the function. It's actually happening in the print statement. So I'd have to put a try except here if I want that. So if I did this, notice how it prints whoops now. That's because when I said mean of two lists, it never even tried to run this code. I never encountered this try except block because I didn't get in. I failed to enter in the first place. So the try and except block actually has to be here. It's like an if statement. An if statement inside the function only runs if you can get into the function. However, I can still do stuff like hello, because hello will get me into the function. However, it fails the try statement. It's not zero division error, so it doesn't get here, which means it gets here. Okay. I know it's a bit new, but the idea shouldn't be scary. If you guys understand if statements, it's very much the same concept, but only for errors. So I'm assuming from the silence it's safe for me to move on to garbage in, garbage out. I've got a thumbs up from Hussein, so I'm gonna move on to garbage in, garbage out. Garbage in, garbage out is a concept that you guys probably have heard Nick mention once or twice in lecture. Basically, if we make a function and we give you crap, if we give you a invalid variable or we give you data that just makes no sense, you're going to get an output that just makes no sense. Garbage in, garbage out. So let's take a look at a quick question. We're going to ignore this comment for a moment. We're just going to code the question, not assuming any errors. So what is the question? The question is going to be starting at A, going to B, using step of S, return a number, or return a list of numbers. So this is very much your Python range function. If you did Python range ABS, that's what I'm looking to code here. However, I'm going to do it manually. So I'm going to make an answer list. And what I'm going to do is I'm going to start at A, and I'm going to go until I am bigger than B, and I'm going to go by steps S. So while A is less than B, I'm going to do answer dot append A, a plus equals s. I'm not going to make a counter variable. I don't need a variable I because I is just a. It's the same general process. If you guys are more comfortable with seeing it that way, you could do I equals a, while I less than b, and you could replace all occurrences of a with I. This is the exact same code. However, a doesn't get mutated. But I'm just going to do this because it's more fun. So this works for your general case. So if I did a print counter, let's say I want to go from 5 to 10 in steps of 2. So 5, 7, 9. Works as intended. What are some edge cases that you would want to account for? Well, okay, if I were thinking about this logically, what if s is 0 or negative? That's a problem. So what if s is not positive? If s is less than or equal to 0, then I should return some sort of return false. However, whoops, if I then do 0, notice how it's still it's a value. It's a value you could work with. What if I want it to error? How do I get Python to throw one of those really violent error screens? Well, instead of returning false, I will use the raise keyword. Raise in Python literally just means force an error, scream. So if I were to say raise type error, and I ran this, now it's a type error. It tells me exactly what line of code was the problem, shows me the test case. It's a proper error now. And this could be any error. It could be value error. If I thought value error better suit the data, it's now a value error. I could do 0 division error. It doesn't make much sense, but I can do it. Raise is a great keyword, but it's not really an error that already exists. What if I want to make a custom error? Ooh, this is going to be fun because we have to look at something that we're going to cover 2 weeks from now, something called class. You guys are not expected to understand this yet. I just want you guys to know how to do it because you have an assignment where you need to do this. So I want to make a S not positive error. And I want it to be called S not positive, exactly like this. I want to be able to raise S not positive. So in order to do that, you do class S not positive, then in brackets, pass in exception. You guys will understand what this means in 2 weeks, and then just type pass. This is how you make a custom exception. I will come back to this when we get to the object-oriented part of the course and explain in depth what this is doing. For now, it is outside of the scope of what I'm teaching you. So just know this is how you do it. You don't need to understand what's happening quite yet. Okay? And if I run this, I now get an S is not positive error. And because I've passed an exception, if I were to do try this except S not positive, print oof, and then I'll put a generic except block so that way you guys can see not me. If I run this, it gets caught in this exception because S not positive is now a registered exception. It's not generic, it is specifically S not positive.
Sorry, does your computer know what S not positive is, as in like what sort of error it is?
Nope. We
So
only know.
Go
ahead. Go ahead.
I guess what I'm confused by is that over there, wouldn't any error generate S not positive and like return oof, and then you'd never get to the next thing?
Well, so if I were to do return a divided by 0. I'm just doing this so that way I can show you that return a divided by 0. If I pass in something that doesn't get into this if statement, it doesn't raise an s not positive, it then runs this instruction. And notice how it said not me. That's because the exception isn't s not positive, it's division by 0.
Got it. Okay.
So each exception is very, very meticulously categorized. If I do accept exception as E and I add E to my print statement, I can actually see division by 0. That is the error that it saw. But if I go back and change S to be back to not positive, it doesn't reach there because we specifically raised S not positive.
Got it. Thank you.
Coolio. All right. Enough of these examples. Let's get to the real stuff. This is something that you would expect to see in an assignment or in a test. Write a function decimal to base that takes a positive integer n and translates it to base 36. This should be the word it, not in. Normally on an exam or test or something like that, you guys will see if n is not positive, raise value error or something like that. If we will tell you if this case, raise this error, or if this error, do this. And if you ever see either of those, you know that you guys are expected to use try or accept. The question almost always makes it explicitly clear when we want you to use try or accept. And if you're ever confused, Piazza's available, TAs are available, you can always ask. So, decimal to base 36. The idea behind this isn't what is hard, it's the checking of values. So let's say, what's a good example? Well, I just said, if n is not strictly positive, let's return a value error. So let's do that. Let's, if n is less than 0, actually, we'll do less than or equal to 0. We want it to be strictly a positive number. Let's go ahead and do that. Do we want it to be a strictly positive number? Yeah, we'll do strictly positive. I'm just being funky. So, let's raise a value error. What happens though if we want to actually make an error message? Remember here, when I didn't try and accept this value, it says S not positive, but there's no text, there's no description of what's actually going on. The error is blank. We know the error name, but we don't know information about it. If I go back and do a divided by 0, see how it's 0 division error, division by 0. Python gives us a little extra information. What if we want to do that? We won't test you on this extra information, but it's very helpful as a coder to just add it for yourself. Well, you can do that by treating the error like a function. Pass in a string of what you want it to say. N must be greater than 0. This will take this string and return it with the message. So let's make a test case to show that. Print. So if I run this and then run this, notice how it says value error, which is here, and then n must be greater than 0, which is our custom string that we passed in. Like I said, we will never test you on a test. This is just as valid as this, which is just as valid as this. You guys do it however you feel more comfortable, but it is always helpful to give messages like this so you know exactly where in the code it went wrong. So if n's not 0, we'll return that custom message. What's another situation? Well, I stated it has to be a positive integer. So if it's a floating point number, we should also get an error. So let's do if type n does not equal int, then let's raise a type error. That makes more sense than a value error. And we'll pass in another one of these really helpful. N is not an integer. Nice, quick, simple. Not gonna get too creative with our error messages. So let's assume these are the only two things that the test or assignment asks for. From here on, we just have to code the question. Now, you guys have seen base conversions pretty frequently. I'm not going to go over them, but let's just quickly code the gobbledygook. I'm going to use something in Python you guys probably haven't seen or ever done. You can actually define a function inside a function, and I'm going to do that purely because it's just I don't need it to be universal. Like I don't need dec to 36 to be seen by the function down here or the functions up here. But I want the function because it's more convenient. So I'm just going to code the function inside the function. So that way I can only call it inside the function. You guys probably haven't seen that before, but just know that's a thing you can do. What's a base 36 alphabet? 1, 2, 3, 4, 5, 6. Whoops. 7, 8, 9, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. That's the alphabet we're looking for. And then all we would do is we return, alphabet at the index of n. We're assuming n is an index. I could also call it I. I don't have to call it n. I just like calling it n. And then we're going to code it. So what is the code? Answer is an empty string. While n is strictly positive, what we're going to do is answer equals, we're going to use that function that I just made in order to find the letter. So I'm going to take n. I'm going to do mod 36. I'm going to find out that that remainder. And then I'm going to take the letter at that index. So if I had 37 mod 36 is 1. I need the item at index 1, which is 1. And then what I want is 1 plus whatever letters should come after that. And then I'm going to shrink n so that way I don't then get 37 again. Because after 37, I've already counted for 36 numbers, so I want to go down. I want to go down and just have 1. Because if you think about it, the number 37 is 1 plus 36. 36 is its own number, and 1 is its own number. And then finally, I'm going to return ants. Base conversions are something you guys probably have seen 100 times at this point. But if I run the function, I get 11. It's not actually 11. If you guys think about it, it's a 1, 1, because it's 1 plus 36 times 1. If I did 142, that's whatever y is value 35. So 35 plus 3 times 36. If I pulled up a calculator, let's just boop. 3 times 36 plus 35 is 143. Oh yes, it's 0 indexed, so it's actually 34. My bad. So 3 times 36 plus 34 is 142. I forgot the 0. Anyways. So this is an example of like how you guys would likely use error checking on an assignment or a test. We would give you a series of if this is true, do this statements. So if n is not an integer, raise type error. And what you guys would have to do is you would have to go through each of the bullet points, identify the condition, code the condition, take the result, raise the result. Then you guys would code the problem as if it wasn't an issue.
I have a quick question.
Hit me.
So in this question, you've told us like if n is not positive, raise value error. Should I know which types of errors are appropriate for which types of situations?
You will never need to natively know that. In a test or an assignment, we will always explicitly state the type of error you will throw. So if we want a value error, we will throw a value error. If we want a type error, we will throw a type error. If you were coding for yourself, there is a logic to what error you would naturally throw. So there are the easy ones. Zero division error only occurs when you divide by zero. Assertion error only accrues when you attempt to assert something that is false. Stuff like that. But there's a really good website. I'm pretty sure. I can't remember what it is. Python error. Whoops, I'm in caps lock. I can't quite recall. Here we go. So if you go just to Python source code documentation, there's a whole bunch of errors, and like they each have a description. This is when you would choose to use a error. So you only use an index error when a sequence is out of range. If index is not an integer, it says use type error instead. Like there is a logic to all of these, and Python very, very clearly states what the logic is. But on a test, we will always explicitly tell you the type of error we're looking for.
Got it. Thank you.
And I'm a pretty big stickler when we're defining like errors in an exam, not the assignments, but in a test or exam, I make sure all of the errors conform to the standard. So if this says throw a value error instead of a type error, I will throw a value error instead of a type error. But that's just me. The other TAs aren't expected to follow that standard. As a fun exercise, though, to you guys, I didn't plan on going through it. I just put once you're done, write a function base 36 to decimal that just reverses the old function. So decimal to 36, base 36 to decimal just does the exact same thing in reverse. I can go over that if you guys want. I'm just going to make a quick translate function because, again, it's going to be really helpful. And all it does is, given a string, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, whoops, O, P, Q, R, S, T, U, V, W, X, Y, Z, da, da, da. I'm going to return the index of whatever character I pass in. So if you could imagine this as char, and I'm going to return the index of that char, because if you think about it, this is at index 0, its value 0. Number 3 is at index 3. Number k is at whatever index k should be, etc., etc. It makes general sense. Some value equals 0 because I need something to add to, and I'm going to start at I'm going to make a column, so to speak, and that's just in the number. If I had 3y, I need to start at y, take the smallest value, so 36. It would be 36 to the power 0, and then I would. What's a good way to explain this? 36 to the power of 0, multiply that by the index of y, add that to sum. This is 36 to the power of 1, find the index of that, multiply it by sum. So I need some sort of, perhaps a better way to say it is exponent. Exponent And it should actually be 0. My apologies. So for char in S, now remember, I want to start at the right-hand side, not the left-hand side. So it will be easier if I just reverse the string now. So for every character starting at the right, what I'm going to do is sum value plus equals the translate function using that char. I'm going to multiply it then by 36 to the power of exponent. So exponent is 0. This would result as 0. If exponent is 1, it's 36, 36 squared, etc., etc. Then exponent will, actually, I just need plus equals 1. So I'm going to keep increasing the power of 36, and I'm going to keep adding until I have finished my entire string. Finally, some value. Da, 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 da. So if I know that 142 makes the value 3y, passing in 3y should return 142. S is not defined. Lol, I called it N. Should have been S. That's my bad. 142. Because I'm passing in a string, not a number.
Sorry, could you remind me what it means to say for char in S and then the brackets and then the 2 colons?
So this is a short form notation that Nick covered for reversed S. All it does is it reverses the string. So if you think about it, you have start and step, right? So if I pass in no start, it assumes I begin at the beginning of the string. If I pass in no end, it assumes I'm going to the end of the string. Step, however, is what's really important because I want to start at the right side and work my way leftwards. I need to go -1. I need to go backwards, if you think about it.
Thank you.
And I should say, when you go backwards, Python actually natively flips these because you want to start at the end and work your way back to the beginning. And this, I have no idea what the default values are for a reverse string. This is why I never put them. This is actually, I should say, I don't use this notation normally. This is the notation that Nick taught, so I felt I would go over it. When I actually code, I would type reversed S. Python's slicing notation is flawed. They failed to explain it, in my opinion, so I almost never use it. I like this. I think this is prettier to look at. And if I wanted only a specific part of this, I would then do, say, 1 to 3. But I don't like their colon type situation that they've got going on. I'm not a fan of that. Anyways, tutorial is done. Class starts at 9:30, which means that you guys have ample time to ask questions. So don't let that go to waste. This is your chance. The ultimate chance. Or you guys could catch some sleep before class, even though I wouldn't advise that. You don't have to raise your hand, man. Just unmute and go crazy.
Hey, can you just re-explain try, except, and exceptions like in the beginning?
Yeah. Just go over this quick block.
Yeah, exception. Yeah.
Okay, so let's ignore this one because this is the exact same as saying this, but it's safer.
Okay.
So every exception As you can see, when I defined a custom exception, you see how I passed in exception to it? Like I told it, you are an exception. The reason I did this was so that way, if I say except, if I tell it only to look for exceptions, we don't get that infinite loop error. Well, I do while true, and I want to print hello. Or I'm gonna do input hello, and I'm going to print hello. So that way it pauses. I want to show you why this is so helpful. So this is an infinite loop, right? You would escape to cancel. If I want to stop this, I use keyboard interrupt to stop it. This lets me out of the loop. What happens if I'm in a try and except block though? So I'm going to try to do this code. And then I'm just going to have a generic except as to stop me from doing something that might break it. Let's just type trapped so you can see exactly what's happening. I'm going to run the loop. It's going to prompt me for an input. But if I try to break this, I'm trapped. You see how the loop is still going. To this minute, the loop is still going. In fact, I actually can't stop it. I just killed my notebook. This is because except will also grab that thing that kills the loop. When I say except exception, and I then try to kill it, I'm now allowed back out. That's the only reason I advise you guys to accept exception instead of just accept. But what is try and accept? You had a question, or do you want me to keep going?
Oh, I just had a quick question
Yeah.
about what's with the as e? What does that do? Like accept
as
exception.
e makes it a variable. So notice how it says keyboard interrupt interrupted by user. If I do as e, I can then take this text, whatever this text is right here, and I could print it. I could use it as an actual variable. So if I kill it and I scroll to the bottom, whoops. Hold on. I have to get rid of this, do that, and if I kill this, it's still not working. Oh, I'm accepting exception. Error equals, I'm going to save the inputs to A. I'm going to do error int A divide by 0, just for an example, because I need to actually trigger an exception. So if I type any number, that text then gets printed right here. This variable is whatever my error text is. That's why I say as E, so that way I still have access to that.
Okay, that makes sense. Thank you.
Is there any situation in which you would not want to say exception as e?
Like where you would want to just have this?
Yeah.
You're looking at me on a screen, correct?
Yeah.
What happens what do you think happens when your mouse goes off screen?
I'm not sure.
Well, fun fact, Windows screams. It screams internally. When it loses your mouse, it's actually constantly, it's essentially an infinite loop. However, your mouse is no longer on cursor. It's failing this try block. It's constantly hitting an accept block.
Mm-hmm.
But would you want your GUI to just crash? Because notice, like the accept blocks, we could have it like crash.
Mm-hmm.
Well, in a GUI, you don't want the loop to ever end. You never want the loop to ever end because that's what controls how the person sees the content, right?
Right.
So in a situation like that where the loop should never end, they should never be able to break it. Having this is actually a security risk because they could crash the GUI.
Got it. Okay.
It's
That makes
a
sense.
very rare situation, but it is a situation.
Thank you.
No problem. Anyways, Hussein, I didn't catch. Do you understand this part of the try and accept, and it was just this part that you wanted me to cover?
Yeah. The try and accept part, that was okay. Just the part when that part I was a bit
Yeah.
confused at, but now it's good. Thank you.
Yeah, this is just the safest way to essentially write else. Now, fun fact, and you guys will hate this, when Nick is covering try and accept, he will cover 2 more keywords that try and accept actually accepts. Finally, that is one of the keywords, where finally is if try happens, it still runs this. If accept happens, it still runs that. Like, no matter which one of these branches you enter, you also enter finally. So if I did A equals the sum, A equals false, or A equals whoopsie, and my finally block will be return A. So I will always enter one of these blocks, but my final instruction will be to return the value of A. You will never, ever, ever be tested on a situation where you need the keyword finally, or in a situation where you need else in a try and accept block, because else is also a keyword that works for try and accept. It's extremely hard to explain what else does in a try and accept. Like, there are legitimate, if I go on website, try accepts finally else Python, the only website I found that actually manages to really do a decent job at explaining it is Geeks for Geeks. I love Geeks for Geeks because if there is no exception, this will run. That's how it works. So basically, let's say I give you this code, print I worked. What happens is try runs does this. If no exception occurs, it first enters the else and prints I worked, then enters the finally and returns A. However, if you divide by 0, it enters this block, which means the else statement no longer happens. You did enter and accept. The moment you enter and accept, else never triggers. However, finally still triggers. It is the most confusing situation I have ever tried to explain to anyone, and you will never be tested on a situation where you need it. Because you don't need it. As I mentioned earlier, I could do return A in here and make my finally useless. And if I want an else statement, why not just put it in here? Put it in the try. You don't need else. For the scope of this course, you never need the additional keywords. They're very niche. In the scope of a proper Python project, they're actually kind of helpful. Like, I have worked on personal projects where I have used else and finally, but you do not need them. Not for this course. All right. That's my quick rant. Any more questions, guys?
Just one more thing. How
Yeah.
you talk about like you can put an else in the try block? How does that like work? I don't know what I'm getting, but like
So, like, you're wondering what the else keyword does, or just like how does it tell the difference between tries else and a if else?
Oh,
Because it is
well,
it is
kind of
confusing that
both.
Python uses the same keyword twice. So
like
try is actually a disguise. It is essentially a Halloween costume of a word. It's essentially doing if this not exception. Something similar to this. This isn't exactly what Python does, but that's why else works. So sorry, if this is exception, else is if it's not an exception. That's how the else keyword works. So only if this code works. If A returns a value, the else block will run. But if A is an exception, we go into the except blocks, and because of that, else will never run. Does that make sense?
yeah.
So this
But
has
you
to work
said
for
like
this.
else can be in the try block.
Yeah. So else, like else, you see how it's on the same level with except and try?
Yes.
This basically says that we are all for the same thing. Else only reacts to the item right before it. So if what I did is if let's say A equals B or something like that. I don't know what A and B are. This else is now bound to this if. It's no longer bound to this try because something came before it.
Okay, okay. That makes a lot more sense.
So as long as you have no if statement on the same level, this else and this try are now linked. I like your questions. You actually are challenging me here. So yeah, I do a value, it prints I worked. But if I do a situation like this, it doesn't print I worked anymore because it didn't. This try didn't work, so this else didn't work.
Just one last thing. If
Yep.
the try worked and the accept worked, else wouldn't work, right?
The try and the accept can't both happen. If this has any error for any reason, the try will fail.
Oh, okay.
You will either be in try or you will either be in accept, but you will never manage to be in both. It's not possible.
So any error in try means
Will put you in accept.
okay, that makes sense.
But that doesn't mean you have to have an exception for it. If I do this and I pass in something that, like if I pass in a string, I have a zero division error, but I don't have an incompatible type error, which means that I will still error because my try failed, but I did not have an exception to make up for that try failing.
Okay, that makes sense. Thank you.
All right, you should get to class, man.
All right, have a good one.
And you.